warahmatullahi wabarakatuh. Let's continue with the application of derivative in business and economics. So here I'm not going to look at different types of rules of differentiation anymore, but I go straight to the application. So I expect that all of you are very familiar with the derivative. Okay, so the first thing that can be related to derivative is the use of derivative in a calculation of elasticity of demand. Now, if you have taken principle of microeconomics, then I'm sure you have learned elasticity of demand. So before we learn elasticity of demand, we learned about law of demand, and law of demand says that for any consumers, if price of a product increases, then the quantity demanded for that product will decrease. Okay, but the responsiveness varies between consumers. All right, so and also varies between products. So I'm talking about the degree of responsiveness here. For instance, this is a textbook example. If we have an insulin and an increase in price of insulin, right? Because insulin is needed for some types of illnesses, especially those with diabetes. And then even if the price is increasing, the quantity demanded will not greatly decrease because you need it if you have diabetes. So, but then if you compare with other types of product, for instance, clothes, if there is a change in the price, let's say increase in the price a little bit, then there's a tendency for consumer not to buy it. Okay, the responsiveness is very very obvious because they can wait or they can say that it's expensive. All right, they can still wear their old clothes, for instance. So in this case, for the first example here, the consumer is not very responsive for the demand for insulin when the price changes, quantity demanded. When the price changes, it means that the consumers are not very elastic. Okay, I mean the demand. But then for the second example here, the demand is very elastic. So here, when the price changes cause relatively small changes in demand for a product, then we say it is inelastic, like in the case of insulin. But in the case of clothes, it is very elastic. Okay, so how do we measure the elasticity of demand, or in particular the price elasticity of demand? The formula, let's say we have quantity equivalent to QA at the price of PA. PA could be $5, $6, whatever, and let's say at $5 the quantity is 10. I'm just making up, yeah. Then the formula is given by this, and then this symbol is basically eta is equivalent to minus P over Q times dQ over dP. So here you see this one. This one is basically the slope of demand function, yeah? And then it is included in the calculation of the formula of elasticity, which is evaluated at quantity QA and price PA. Okay, so this is the formula that you need to remember. Alright, now let's look at the example so that you don't really have to suffer in terms of memorizing the formula. Let's say we have this example 1, elasticity. Let's say we have this demand function, P plus 5Q equivalent to 100. Now find the elasticity value when the price is at 40, when the price is at 60, when the price is at 50. Okay, now, so if you see here, what we need to do is that we bring all the number to the right hand side so that we are left with Q only on the left hand side, so that we can have functions such that Q as a function of P. That's what we want. Okay, so when we try to bring everything to the right hand side, so when you try to simplify, so you have 5Q equivalent to minus P plus 100 in it. So you have Q equivalent to minus 1/5 P plus 100 divided by 5, and simplify further, you're going to have minus 1/5 plus P plus 20. So this is the demand function. You can also express it in the form of P as a function of Q, Okay, but because I want to find in the formula, if you can recall back the formula, eta minus P over Q times dQ over dP. So that's why I bring Q on the left hand side so that I can differentiate Q with respect to P. Okay, so in this case, the formula here, eta minus P over Q times, you differentiate the demand function here with respect to P. So dQ over dP, you get minus 1/5. So you can plug in into the formula, minus 1/5. Now you see the sign minus here, from here, is actually just to show you the relationship between Q and P for demand, quantity demanded. Remember, this is to show law of demand. Now, maybe you wonder, why do we have minus sign in this elasticity formula? In the elasticity formula, when we have minus sign here for the demand, price of elasticity of demand, we just want to get rid of this minus sign here. That's why we put minus sign here, so that we get positive answer, because we just want to concern about the value, not the sign. Okay, because the sign here is nothing else, just to show you law of demand. So we want to abolish the sign, we put minus sign here in the elasticity formula. I hope this is clear for you. All right, or another way is, if you read other textbooks, sometimes they don't put minus sign here. Okay, sometimes they do it this. So you have PQ times dQ over dP, but you put the absolute term so that the minus sign is abolished. Alright, now let's go to question E. When the price is 40, so you have price equivalent to 40, you look at the formula. Let me clear this thing so that it doesn't look a mess. So when you look at the formula here, you need to have P is given, you need to have Q, and you need to have dQ over dP over dP, you have found it earlier. Let me erase this here, because otherwise it becomes a mess. Okay, so here you need to find Q, plug in into the formula, then you can solve for elasticity. So with price equivalent to 40, you have this demand function, then you just need to plug in. So you have Q equivalent to minus 1/5 times 40 plus 20. What do you get for quantity? You're gonna get 12 as quantity, yeah? Alright, so here, so your eta elasticity of demand will be minus 40 over 12 times minus 1/5. What do you get? 2/3, isn't it? Now 2/3 here is less than 1. Okay. What about if the price is 60? What about if the price is 50? Can you do the same? So please do the same, yeah? Okay. Now here I have the answer for all of this, but I don't show you the method for B and C. I request you to do it on your own. Follow the step that I've shown you here for A. And then next, I want to show you, if you see here, eta is 2/3. The elasticity of demand is 2/3. When the quantity is at 12, the price is at 40. This is question A that I already solved for you. When this is given to you, then I simplify it, so becomes Q minus 1/5 P plus 20, isn't it? Alright, and then you can see here, it says slope M is minus 5. But why the slope here is minus 1/5? Because I express it in the form of Q as a function of P. You're gonna get slope equivalent to 5 if you express this in the form of the other way around, P as a function of Q. Here, Q as a function of P. 5 minus 5 slope when you try to put it in this form. Okay? Now, for question B, if the price is at 60, quantity will be 8. Yeah? This one, you solve it yourself. And the elasticity of demand is also 2/3. But when the price is 50, quantity is 10. Okay, this is question C. I didn't show you how to get it, but I expect you to do it. The elasticity of demand is 1. So here you can see, if we try to put the demand curve in the form of graph like this, but in this graph, it shows price as a function of Q. What I did for you is Q as a function of price. Now, I want you to try at home. Instead of Q as a function of P, you use this P plus 5Q equivalent to 100. Rearrange it such that P is on the left hand side, the rest is on the right hand side, including Q and numbers. Then you can have what we call P as a function of Q. And then after that, you draw a graph similar to this. Remember, when you want to draw, you need to know the vertical and horizontal intercept. You need to know the direction. That means you need to find the slope. And the slope is going to be -5 here when you express it this way. And then you need to find the shape. All of this has been answered here, except the justification. It's just draw you, but it didn't show you the 3 things here. But I want to show the 3 things so that you know why the graph looks like this for P as a function of Q. Okay, then you can see here, at quantity equivalent to 10, price equivalent to 50 here, all right, the elasticity of demand is 1. Okay, all right, now, but if price is equivalent to 12, okay, or price equivalent to 8, which is somewhere here, is it price somewhere here below 20, and then you can see elasticity is 2/3. So we're talking about this segment of demand curve. This segment of demand curve, let me erase the mess, the elasticity value is less than 1, isn't it? 2/3 is less than 1. Okay, so that means any price above 50, elasticity must be greater than 1, isn't it? But it's just that I didn't show you in the form of exercise, alright? Because all of this exercise here shows you, for instance, A, okay, and B shows you elasticity 2/3, which is less than 1. C shows you elasticity equivalent to 1. That means, wait a minute, yeah? Right. So that means, okay, any price, let's say you pick 80 or you pick 100, the answer should give you elasticity greater than. Okay, let me do some corrections here. There are some corrections that I realized just now, because I don't want to fix the previous video segment. So if you see here, there's a correction for B, question B, which is price is at 60. There's a correction. Okay, so for elasticity, it shouldn't be 2/3 here. Yeah? It should be 3/2. That means equivalent to 1.5. Because, let me erase the mess here. If the price is, 60 with the quantity equivalent to 8, then the price is above 50. When the price is 50, elasticity is 1. So it can't be that when the price is 60, the price elasticity is less than 1, because price 60 is above 50. So I'm talking about this segment of demand curve, isn't it? Alright, so that means, alright, if you recalculate again the elasticity, you're going to get 3/2, which is 1.5 if we simplify it, which is more than 1. Okay, so again, so 60 is here, so quantity 8 is here, so it is at this point, which is elasticity segment is greater than 1. Okay, alright, if you have good background in principle of micro, then you get what I'm talking about here. Okay, now let's move to the next one. Alright, you can see here along the curve, be it P here, Q here, or when you have P as a function of Q, or the one that I have for you, Q, P here, okay, Q as a function of P, in which I have Q equivalent to 1/5 P plus 20. This is what I showed to you. But I want you to also try to put it in this way so that you can check your graph with this. Okay. Alright, but let's go back to this. Alright, so you can see here, the slope, if you draw like my way here, dq over dp is minus 1/5, isn't it? But the slope, if you draw this way, you're going to get dp over dq equivalent to m equivalent to minus 5, which is this, isn't it? This, yeah? The one that I already make a mess. This, isn't it? If you have this kind of function. But they are all the same story, yeah? Alright. So the slope along the line, because it's a straight line, is always the same. But if you see the elasticity of demand, it's not the same along the line, because along the line here, okay, this one is less than, more than 1. This one, eta equal to 1. This one, less than 1, isn't it? Alright? So although the slope is the same along the same curve, the elasticity won't be the same. Because in elasticity, alright, for different point along the graph, different point of price and quantity will affect the formula of elasticity. This one is the slope. The slope always the same. But P over Q, okay, always changes because it depends on which point along the curve you are talking about, the demand curve. Alright, now, let me erase the mess. Okay, so if the elasticity that you get is more than 1, like question B, in which price equivalent to 60 when the quantity equivalent to it, so you have elasticity 1.5, isn't it, which is more than 1, then we call the demand as elastic. How do we interpret this? If there is an increase in price by 1%, not 1 unit, yeah? 1%, the quantity demanded decrease or increase? Decrease, because law of demand has negative relationship between price and quantity demanded, isn't it? Will decrease by 1.5%. Okay? Okay, so the percentage decrease is quantity demanded is more than percentage increase in price. Because price increases by 1, quantity demanded decreases by 1.5%. So that is elastic. Okay. But then, if you look at question A, in which price is 40, and quantity demanded that we found earlier is 12, and then elasticity is 2/3, which is less than 1, okay? So that means 0.67. If there is an increase in price by 1%, quantity demanded, because law of demand, yeah, decreases by 0.67%. Okay, 0.67% is less than 1%. So it is inelastic, very less responsive. But if elasticity is 1, like example number 3, in which price C, 50, and then quantity demanded is equivalent to what? Equivalent to 10. And then elasticity is 1. Then we can say if there is an increase in price by 1%, quantity demanded decreases by 1%. Okay, then we call it unitary elastic. The percentage change in demand is just the same as percentage change in price. Okay, now the elasticity has something to do with revenue. How do we explain it? We're going to use a generic function to explain how can we check the relationship between revenue and also elasticity. Here, if you can recall back in the study of principle of micro, in order to get revenue, it is price times quantity, isn't it? If we can recall back from the previous example, I've shown you that quantity is a function of price. Okay, so here I'm using generic function. So that means, so if I have Q as a function of price, I can change F, here as, let's say, Q as a function of price like this, so that I can show something here, yeah? Otherwise, it's a bit difficult for me to explain it to you, especially for those who are not familiar with differentiation of generic function. Okay, so I have revenue function that looks like this. Because I know that Q is a function of P, initially I wrote it this way, but I changed the alphabet from F to Q here. Okay, then I can also rewrite it this way, P times Q as a function of P. You get what I mean here? Alright, so as a consequence, if I want to see what happens to revenue if there is a change in price. If I want to see what happens to revenue if there is a change in price, I can do this by taking derivative of revenue with respect to price. The derivative here means what? If there is a change in price by 1 unit, what will happen to revenue? That is the use of derivative. If there is a change in price, what will happen? How much there will be change in revenue? This can be found by taking derivative of revenue function with respect to price. How do we do it? Okay, so if you see the formula of revenue, you have P, you have Q here, but Q here is a function of P. So we can do the differentiation by having product rule, because you have first function here and second function that consists of P. You get what I mean? Okay, so let's say, all right, I hold, let's say this one is A, this one is B. I hold P in A here constant, and then I differentiate Q with respect to P. When I differentiate Q with respect to P, because it's a generic function, then I don't know the exact answer, I just put the symbol, dq over dp. But don't forget to multiply by P, because we are using product rule, yeah? P times dq over dp, settle. Then we put plus a sign because of product rule. Okay. And then we differentiate P, we hold Q constant. So you see Q here, when you differentiate P, it becomes 1, isn't it? So Q times 1. Alright? So Q times 1. Now what you see in the second line here is nothing else, but the second line here, as you can see, you multiply both sides by Q over Q, okay, by Q over Q. In the second line, multiply both sides by Q over Q. You see here, let me show you something. Let me erase this so that it doesn't look a mess. You see plus sign here, okay, similar, yeah? But you see here, initially you have P and you have dq over dp. What is the addition bit? The addition bit is q over q. After plus sign, you see q times 1. You can always put q over q here, but it's just the same. It becomes 1, isn't it? That's why it is not written there. Okay? And then, if you rearrange nicely, look at this. Q over q times p times dq over dp. If you rearrange nicely, P here together with over Q and then Q here, this, and then Q here you bring here. That's why it becomes like this. You get me? Okay? Then you can see clearly, alright, anything before plus sign, do you realize what is this? This is actually the formula of elasticity. But in the original formula of elasticity that you saw earlier, which is this, yeah, is there is a minus sign, isn't it? Just to delete the minus sign comes from the slope of the demand curve. But what happens here is that the minus sign in this doesn't exist, isn't it? So it means it's not just eta, it is minus eta for this sign. You get me? Like because P over Q with minus sign from the original formula of elasticity, you bring minus sign here, it becomes minus eta, then you can get positive P over Q times dQ over dP, and this one isn't it similar to this? Okay, then the next line, let me erase the mess. The next line you can see Q is this, the whole thing here is this, don't forget the minus sign, this one is this, plus is this, isn't it? Then you write nicely in the last line Q times 1 minus eta. Why? Because, you see here, why it becomes Q in bracket 1 minus eta? Because this and this you can factorize. So you're going to get this. Clear? Now, we can use this, I rewrite it again here, equivalent to Q 1 minus eta. You have this, you can show the relationship between eta, which is elasticity, and revenue when we change the price. Okay? Alright. Now, you see here, elasticity and revenue. The rate of change of revenue with respect to price, the rate of change of revenue with respect to price, this refers to dr over dp, yeah? Alright? And I rewrite again, it is equivalent to Q1 minus eta. Okay. This one will become less than 0 if eta here is greater than 1. Let's say eta is 1.5, like in example number C, yeah? In which price equivalent to 60. So eta will be 1.5. When eta 1.5 here, so the whole thing here will give you negative value. And then the whole thing here will be negative value. That means this one is less than 0, isn't it? So when it is less than 0, dr over dp less than 0, how do you interpret dr over dp less than 0? If p increases, r decreases. If price increases, revenue decreases. Or if price decreases, revenue increases. Negative relationship between r and p when eta is greater than 1. On the other hand, if the eta value is less than 1, then you could expect the whole thing here becomes positive. So if price increases, revenue also increases and vice versa. Okay, but if it is equivalent to 1, okay, let me erase this. One minus eta. Imagine this one equivalent to 1, so the whole thing becomes 0. This one becomes 0, dr over dp becomes 0, means what? If price increases, revenue is no change. dr no change in revenue. Hence, an increase or decrease in price will not change in revenue. Revenue is optimized at this point. Okay? What does it mean by optimize? It means revenue is maximized at this point. So you can see, I can actually show you in the form of graph, yeah? So let's say I'm using this graph. Where is it? This graph. I'm talking about this graph. Let me erase the mess. I erase the mess. I'm using the textbook graph, the graph which I didn't use for my exercise. The graph that I used to show you the exercise is this, the function. but this function can also be rewritten as this function. Alright, so I use this. Now, if I try to put it in the form of this, so you have 100 here, and then you have 20 here, Q here, and then here 50, sorry, should be 50 here price, and then here 10. We know that eta here is 1, but eta here, elasticity of demand, is more than 1. This one less than 1 elasticity of demand. So if I try to put in the form of graph, total revenue, at quantity 10, it looks like this. 20 here, 0 here. Okay, can you see? Alright. So that's it. Okay. But I can also change this to this, so that you can understand further. That's why if I try to put the drawing, because this one is a bit not related to the price, I change the whole thing. I change the whole thing. If you get confused, you can always consult me, but I just show you two different things at the same time using the same function. So you recall back Q as a function of P, it is Q equivalent to minus 1/5 P plus 20, isn't it? Alright, so if I have Q here, P here, maximum P is 100, minimum P is 0. How do I get it? You get the vertical intercept, horizontal intercept. Okay, and then I don't have to show you how to find 100 and also 20 anymore, because this one you already learned in the previous lecture. So let me do this. Then this one is actually Q 150 plus 20. This is the one that I show you. The one used in the textbook is this one. Okay. Alright, now here. So if I put P here, then it's 100 here, 0. Then here it is 10. Then here it is 50. Okay. So here it's gonna be the other way around. You should know why, because here P is on the vertical axis, Q is on the horizontal axis. So the higher the P, the elasticity is also greater than 1. But my P in this graph is here. The higher the P, we move towards the right, not going up. You get what I mean? So you can see here, when the elasticity in the first segment is less than 1, when you increase the price, total revenue increases. Okay? Because in this region, it is inelastic, less responsive. Okay, so when people are less responsive, they still buy the quantity. The change in quantity demanded is very little because they're less responsive towards the change in price. Okay, but at the higher price level here, you can see if you increase the price to the right with the elasticity greater than 1, people are very elastic, so total revenue will decrease if you increase the price. That's why you can see dr over dp is less than 0 when eta is greater than 1. This one is the opposite. But at this point, maximum point of total revenue, dr over dp equal to 0. Flat, total revenue flat. and elasticity is equivalent to 1. Okay, so that's the relationship that we can see. Alright, so number 1, number 2, number 3. If I try to label number 1, number 2, number 3 in this graph, okay, what it says, number 1, elasticity is more than 1. Elasticity is more than 1, number 1 here, number 2 here, number 3 here. Okay, alright. So now let's look at another example. The demand for a product is given by Q equivalent to 20 minus 1 over 5P. This one, if you are not so sure about the writing, because the typing, Q equivalent to 20 minus 1 over 5P. This is the correct one. Okay, right. Find the point at which demand is of unit elastic, and find interval in which the demand is inelastic and in which it is elastic. Actually, I'm using the same function as before, but let's assume we never saw this function before. So how do we solve this kind of question? Alright, find the point at which demand is unit elastic. First, before you can find whether it is unitary elastic or not, you must remember the formula of elasticity. It is minus PQ times dQ over dP. Okay, let me change it to capital Q so that some of you won't be confused. Capital Q. Okay, now in this case, how do we do it? So I'm trying to answer question A. Question A, minus P over Q times dQ over dP must be 1. Okay, now from this equation, dQ over dP is what? Minus 1/5, isn't it? So, minus P over Q, okay, times minus 1 over 5, 1/5. Okay, next. Okay, so I have my P, I have my Q. What can I do? Substitute my Q back into this function. So I'm gonna have minus P on numerator, I don't have to substitute. 20 minus 1/5 P, okay, then times minus 1 over 5. When you rearrange this, don't you think that you're going to get answer equivalent to 1? Alright? But how to get this? You rearrange it, and then you will see your answer, eta equivalent to 1. Search for P. What is your P? You rearrange it. When you rearrange, you're going to see P equivalent to 50. If you don't believe me, rearrange this, okay, until you get price equivalent to 50. After you get price equivalent to 50, alright, then find Q. How to find Q? Put 5 equivalent to 50 back into Q function, you're going to get 50. Okay, so here you're going to get elasticity equivalent to 1 when price equivalent to 50 and Q equivalent to 10. Okay, but in order to get this, you must rearrange this last line here and solve for P. When you solve for P, you're going to get P equivalent to 50. After that, 50 plug in back into this demand function, you're going to get Q equivalent to 10. Okay, now let's go back to question A because we haven't fully answered question A. So for question A, find the point at which demand is of unitary elastic. The demand will be unitary elastic at the point in which price equivalent to 50 and quantity equivalent to 10. That's the answer. Find interval in which the demand is inelastic and in which it is elastic. How to find the interval? Okay. Graphically, you try to put in the form of graph. So the question give you Q equivalent to 20 minus 1/5 P, isn't it? So draw the graph, P here, Q here. Find the intercepts, vertical and horizontal. Here I don't show you the method, but I just give you the final answer, but you have to show the method, how to find 20, how to find 100. You must show. And you must show why the curve is linear, why it is downsloping. I'm sure by now you should know, yeah? And then if price 50 is here, quantity 10 is here, and we know that eta is 1. Okay? So you need to find the interval in which, eta is less than 1 and eta is, more than 1. Okay? So how do you find it? The price is here. Usually any price above 50, above this threshold, then elasticity will be more than 1. Any price below the threshold price, elasticity will be less than 1. That means elasticity equivalent to 1, price threshold is 50, Q is equivalent to 10. So elasticity more than 1, price must be greater than 50, but the maximum one is 100, isn't it? Because the horizontal intercept is this. So that means for any price above 50, less or equal to than 100, and quantity must be above 10, but less or equal to 20, including 20, then elasticity is more than 1. So elasticity is less than 1, okay? When price is greater than 0, but less than 50, and quantity greater than 0 and less than 10. Okay, this one. Is it clear? So that's the answer for A. Okay, that's the answer for A. Find Q where revenue is increasing, where it is decreasing, where it is maximized. Okay. Alright. Sorry, let's go back to this. So we know that, let me erase this one so that I have space to show you. Okay. We use the concept of derivative to answer question B. How? Okay, first we need to find the revenue function. We know that revenue is P times Q. So we have Q, which is 20 minus 1/5 P multiplied by P. Okay, so this one is Q, isn't it? Alright, then we're gonna get 20P minus 1/5 P square, isn't it? Alright, then we need to find dr over dp. Differentiate revenue with respect to P. What do we get? 20 minus 2/5 P, isn't it? Okay. Then we need to find when it is. We know that, and then based on this answer elasticity, when price is 50, quantity is 10, eta is 1. What happens? So when we set, when this happens, we know that from the theory formula, in this, it shows that when eta is 1, dr over dp is 0. Now, let's check. Okay, set dr over dp equal to 0, and then try to rearrange until you find P. What is P? You're going to get P equivalent to 50. By the way, when you differentiate revenue with respect to P, how do we call this in economics? This is marginal revenue. Okay? Now, when P equal to 50, then you can put 50 back into Q. You can find Q. You're going to get Q equivalent to 10. You know that from A, when P is 50, eta is 1, isn't it? Okay. Marginal revenue equivalent to 0. Because this exercise is just similar to the previous exercise. If you go back to the drawing that I've shown you earlier, let me clear the mess. Yeah. Let me clear the mess. If you see here, just by having this, I don't have to redraw it in the graph. So if you see here, dr over dp is actually the slope of total revenue, isn't it? With respect to price. Price is here, revenue is here. So you can see dr over dp is upsloping between 0 and 50, but becomes 0, you see flat here, at maximum. At maximum, price is 50. And we know that when price is 50, eta, elasticity of demand, is 1. Okay. After that, after 50, total revenue declines. That means dr over dp less than 0. That means the slope declines. The slope is negative, which is shown by this. Okay. Alright. So that means, based on this, I can answer question B. Yeah? Find Q where revenue is increasing, where it is decreasing, where it is maximized. It is maximized when quantity is equivalent to 10. Because dr over dp is 0. When dr over dp is 0, the total revenue curve is at maximum because the slope is 0. dr over dp is 0 here, flat. Total revenue is increasing if quantity is below 50 but above 0, isn't it? Can you see here? Alright. Then dr over dp is greater than 0. The slope is upward sloping. So the range here Q is between 0 to 50 when revenue is increasing. When it is maximized, we have answered. Where it is decreasing, after 50 until 100, which is this. Okay. I'm using the same graph, yes, so I don't have to redraw it again. But you can redraw it again. Just imagine if you're given different demand function, you have to draw it like this also. Okay. So here, okay, so I have answered question B. Using the graphing utility to show the graph of revenue function and confirm the result from part B, I have used this graph. Okay, because it's the same function that I used to explain the previous example. That's why I don't have to redraw it. So I have answered question C. Okay, so that's how example 3. Okay. This is an additional exercise that you could do at home. Yeah? So this one I will discuss it with you. But please try this exercise. It's a very good exercise. And so I hope you try it. Of course, I don't check, but you have to try. Okay, so let's move to another example of the use of derivative, partial derivative. So it's about revenue, cost, and functions of profit. So let's say I use this very typical textbook example. I took one exercise from the textbook, but then I come up with a little bit different question. So the cost of producing a new model of light bulb is 250 ringgit per bulb, and the overhead cost is 5,000. Now, what does it mean by the overhead cost? It's actually the fixed cost. The demand equation for the light bulb is P equivalent to 11.5 minus 0.003x, where x is quantity of bulb, P is the price of bulb. Use that information to find the following revenue function: cost function, profit function, marginal revenue, marginal cost, marginal profit. Alright, now I'm trying to answer question A. So question A, we know that revenue is actually price times quantity. In this case, quantity is X, so we use X instead of Q. Right. So we have P. Now we need to have 11.5 minus 0.003x, the whole thing in bracket, square bracket, multiplied by X. Okay, this X. So this one is P. So when you simplify, then you have revenue function as a function of X, which is 11.5x minus 0.003x squared. That's it. What about cost function? So cost function, you have this information per bulk. The cost is 250 and then the fixed cost. So you know that cost function is variable cost plus fixed cost, isn't it? So in this case, variable cost is 250 times quantity, which is X, plus 5,000. Okay, so if I simplify further, cost as a function of quantity, 250x plus 5,000. So that is the answer. Okay, for B. Profit function is actually revenue minus cost. We know this is our revenue, we know this is our cost, so just do it, plug in and then simplify. Okay, so it becomes 11.5x minus 0.003x squared, and then minus cost function minus 2.5x minus, not plus, 5,000. I have a typo there, it's not 50,000, it should be 5,000. And let me erase the number here. And now it becomes correct. Alright, so here 5,000. So simplify, you're gonna get, I call this as this, I don't even have to be px. So it becomes p, or in English you call it pi, I call it p. Okay, so 11.5x minus 2.5, you have what? You have 9x minus 0.003x squared minus 5,000. Okay, you can always put minus 0.003x squared here in front. Okay, because x squared is there, but because it's a profit function, it's nice to put positive value before minus sign. Otherwise, it gives you a signal that there's some people, they don't understand, they thought that it's a loss. You get what I mean? So in this case, I do rearrange in such a way that the one with the highest power in front instead. Okay, so this is the profit function. I have answered question C. Now next, D. Find the marginal revenue. You have revenue function here. What does it mean by marginal revenue? Marginal revenue is just the slope of revenue function, or the derivative of revenue function with respect to quantity here. Okay, so how do you find it? Delta Rx over delta X. You might be wondering, in the previous example, I used D instead of delta. You can use D, you can use delta. Why? Because in this case, you only have one independent variable, which is quantity X. One independent variable. But if you have more, then you cannot use D. You must use delta because we just differentiate with respect to one variable, not all. Okay. Now, so what's the answer? You're going to have 11.5 minus 0.006x. I hope by now you should know how to do differentiation. Yeah? So this one is actually marginal revenue. Marginal revenue is the slope of revenue function. The slope of revenue function is the derivative of revenue function with respect to x. And then it says what? It says evaluated at x equivalent to 100. So marginal revenue at, x equivalent to 100 is actually equivalent to, I don't have enough space, so I write it here, delta Rx over delta X evaluated at x equivalent to 100 equals to what? So you have 11.5 minus 0.006 x here is 100. You put 100, then you solve it. You should know how to find the answer by now, yeah? Because this is just a matter of calculus. So we have found D. Okay. What about marginal cost? You have, I'm talking about question E now. You have cost function. If marginal revenue is the different derivative of revenue function with respect to x, so marginal cost is the derivative of cost function with respect to x. You differentiate C with respect to x. Okay, so I'm talking about question E. Question E, marginal cost. Differentiate Cx with respect to x. Look at me. Now in this case, let me erase some part here. Or I move a little bit here. That's a good thing about using digital pen. But anyway, all right, so here you differentiate it. What do you get? You're going to get 2.5, but evaluate it at x equivalent to 50. If you evaluate it at x equivalent to 50, what's the answer? Let me move it a little bit. What's the answer? This one I can't remove it. So here, let me write it here. So I'm still answering question E, but I don't have enough space. So E MC at x equivalent to 50, or delta C over delta x evaluated at x equivalent to 50. What's the answer? Because you see here, the result is 2.5 without x. It's a constant. So the answer is always 2.5. That's it. Okay. What about marginal profit? Can you do it on your own? That means this is the profit function. Marginal profit is the slope of profit function. It is the derivative of profit function with respect to x. I want you to find it yourself and then evaluate it at x equivalent to 70. Okay, so I hope you can answer question F, yeah? Alright, so now we are done with the, partial derivative of one independent variable. What if we have two independent variables in the equation? So I'm talking about multivariate calculus. Let's say I show you this example. The demand functions for two related products, product 1 and product 2, are given by this. Q1 refers to quantity of product 1. Q2 refers to quantity of product 2. You can see here Q1 depends on price of good 1 and price of product 2. Similarly, Q2 depends on price of product 1 and price of product 2. Determine the four marginal demands. Marginal, what does it mean? You differentiate this with respect to independent variables. So, I'm trying to answer question A. Let's use function Q1. So, delta Q1, you must use delta, not D, because now you have two variables, independent variables, so you can't use D. D means total derivative, which you don't learn now. Okay, let me erase this first. Okay, so delta Q over delta P1, what do you get? This one, you differentiate, you get minus 5. Delta Q1 over delta P2, you differentiate this, what do you get? 6. Okay, now what about this function? Delta Q2 over delta P1, you get 4. I'm sure you know how to get it now by now, yeah? Delta Q2 over delta P2, you get minus 5. Okay. Let me use red pen. Okay. This red pen, if you see this and this, you differentiate product 1 with respect to its own price. You get minus 5, which is less than 0. Minus means what? If price of good 1 increases, quantity demanded of good 1 decreases by 5 decreases. So minus means there is negative relationship between price of good 1 and also quantity of good 1. There's a negative relationship between quantity demanded for good 1 and its own price. Similarly, there's a negative relationship between You know quantity of good 2 and its own price. So these two are basically talking about law of demand, nothing else. Okay? Alright. But if you look at this, I use different pen now. Let's say I use green pen. For green pen, if there is a change in price of good 2, how much is the change in quantity demanded for good 1? It is 6. 6 is positive. If price of good 2 increases, quantity demanded for good 1 increases as well. That means what? When price of good 2 becomes expensive, people buy more of good 1. Isn't it higher? Similarly, if price of good 1 increases, for this, price of good 1 increases, quantity demanded for good 2 increases. So you can see greater sign than 0 for both of them. So that's how we see at it. Alright. So B, are product 1 and product 2 complementary or competitive? If you want to check whether product 1 and product 2 are complementary or competitive, which partial derivative you should refer to? You should refer to the green ones. There are two greens, and then you should check the results. The results for both greens here shows you the derivative is positive. That means the relationship between price of the good and the the quantity of the good with the price of other goods is positive. When it is positive, it means it's not complementary. Both of them are substitutes. They are competitive. You get me? Because the sign is positive. Is it clear? So I have answered question B. Now, please try to look at the exercise in the textbook. It's more or less like this question also. And I strongly request you to do. Yeah, please. When I say please do, you must do. Okay. Now let's move to another example of multivariate calculus application of partial derivative, which is this. Suppose we have Cobb-Douglas function given by this production function. Z is the output or products, total product. X and Y are the inputs. X refers to, investment. Y refers to labor force, quantity of labor. X refers to capital or investment. Find the marginal productivity of X. That means delta Z over delta X. So that means 300 is constant. Y to the power of 1/3 is also constant. So you just need to differentiate X to the power of 2/3. So how do you do it? 300 stay the same. X to the power of 2/3 becomes what? X to the power of 1 minus 2/3, isn't it? And then 2/3 here, bring it here, isn't it? And then y to the power of 1/3 is a constant. You leave it just like that. And then can you simplify? Okay, here I haven't finished the answer, but I want you to simplify. Because I have done the derivative, the differentiation part. Okay, so this is delta Z over delta Y. You hold Y constant. Okay. B, if the current labor force is 7 to 9 work hours, substitute 7 to 9 in your answer to part A and solve it. Okay. You substitute Y equivalent to 7 to 9 back here and then solve the answer. So I'm sure you know how to do it. Okay. Find the marginal productivity of Y. That means delta Z over delta Y. Okay. This means in this case, you hold 300 constant, you hold X to the power of 2/3 constant, but you differentiate Y to the power of 1/3. So here it becomes what? So let me erase the mess here. Okay, it becomes 300 stay the same. Okay, X to the power of 2/3 stay the same, but Y now becomes what? Y? 1 minus 1/3. Oh, I think I have made mistake here. It shouldn't be this. Not 1 minus 1/3. No wonder I feel a little bit strange in terms of this answer. So it should be 2/3 minus 1. Otherwise, it's going to be wrong. So same with the second one. Okay. The second one, 1/3 minus 1. Then that's correct. Okay, don't forget, 1/3, bring it here. Maybe multiply. And then you simplify the answer. You're going to get the answer here. So D, if the current capital investment is 27, substitute X into your answer here and then simplify. And then solve for what? Find Y. Y equivalent to what? Same with B, find X. X equivalent to what? Okay. Alright. So interpret graph in part B and D. Alright. With regard to what they say about the effects on productivity of an increase in capital investment, part B, and also increase in labor force, part D. Now, I leave this exercise for you to do it. Okay. I leave this exercise for you to do it. So that's it for this application of differentiation for partial derivative for one independent case and also multivariate independent variables case. Alright, so with that, I thank you. Assalamualaikum.